Hi, welcome to my channel Cloud with Girish. How do you build your software application? Do you still rely on manual build process? Do you have a dedicated team member who run the build multiple times a day or handle deployment to development, test or production environments? If so, this workshop is for you. In this video, I will implement an AWS Code Pipeline for a serverless function and API built using AWS Lambda and API Gateway. The function itself is very simple and it returns just a hello world. However, I will demonstrate the process of building the function and API using AWS SAM, which is Serverless Application Model, and validate it locally. Once I have validated the function locally using AWS SAM, I will integrate it with GitHub and AWS Code Pipeline for the CICD. With this CICD pipeline, each time a commit is pushed to the Git repo, AWS Pipeline will be triggered and updated stack will be automatically deployed into the AWS cloud. Before diving in, let's review the architecture diagram to understand how these components interact. Let's look at the architecture. So in the first part of this architecture design diagram, we have a flow indicating that there is a user that's invoking an API. That API is hosted in API Gateway. It's a secure API, it's using the API key and usage plan, and then it's invoking a Lambda function. Lambda function is using integrated CloudWatch log, and this entire flow is built using AWS SAM, which is Serverless Application Model, using the infrastructure as code approach. Now, we want to have a Git repo here, and this Git repo is integrated with the code build, which is another service, and S3 bucket for the artifact, and code pipeline is orchestrating the flow where anytime a code change is committed to the Git repo, it will actually trigger the code pipeline and it will update the Lambda function, resulting in the API to return a more up-to-date response depending on the code changes. We need to have familiarity with AWS Management Console, the basic understanding of AWS CLI, AWS SAM, Lambda API Gateway, and some basic understanding of CI/CD Pipeline and GitHub. Let's get started. We're going to look at the introduction to AWS SAM, an overview of AWS Code Pipeline. We'll review AWS SAM template. We'll review the Lambda function, which is written using Python Boto3 library. We're going to look at the build spec YAML file. This is the file that defines the build and pre-build and deploy stages. We'll also look at committing the code to the Git repo, then we'll configure the code build and we'll create a code pipeline around it. Once all these pieces are in place, then we can push a code change to Git repo, and then we can monitor the code pipeline. So you will see that how the code pipeline is being triggered and all the stages are being built. At the end, we can look at S3 bucket, which we are using for code artifact, and then we can validate also updated Lambda function, review the CloudWatch log, and towards the end, we clean up the resources, which is deleting the pipeline and related resource, delete the IAM role, and so on. So let's look at the introduction to AWS SAM. AWS SAM, which is the abbreviation for Serverless Application Model, is a framework that simplifies the development, testing, and deployment of serverless application on AWS. It uses a template file in YAML format that defines the resources like Lambda function, API, permission policy, and more. With AWS SAM, developers can build and test the Lambda function locally before deploying those to the AWS cloud. An ability to develop and test locally enables the developers to debug the functions in a speedy, reducing the Cycle time for the testing and deployment. With commands like SAM build, SAM local, invoke, and SAM deploy, developer can use command line to accelerate the build, validate, and deploy the resources. Let's look at the AWS Code Pipeline. AWS Code Pipeline is a fully managed serverless service that enables continuous integration and continuous delivery for software application releases. It allows software teams to build CI/CD workflow as a series of stages such as source, build, test, and deploy. AWS Code Pipeline integrates seamlessly with source control tools like GitHub and AWS services such as code build and code deploy. By creating a CI/CD pipeline, team can significantly reduce or even eliminate manual efforts and ensure consistency across different environments like development, testing, and production. This automation empowers team to release software more frequently and reliably. Let's look at Serverless Application Model and Lambda function and API. Let's build a Lambda function and a REST API using AWS SAM. The API will invoke the Lambda function. Lambda function has the code to return just a hello world. When resources are being built using infrastructure as code approach via AWS SAM, all resources are defined in the template YAML file. Let's look at our AWS SAM template.yaml file. As you can see that in this template, I have two key resources defined. One is a hello world function and there is a hello world API. And then within that function, I have various configuration including the properties which say, hey, the function name is hello world function, the architecture, there is a code URI, there is a runtime of Python 3.13, I have the timeout, memory size, and then some policies. I'm also defining an event which tells the telling me that it's a type of API, so it's integrated with the API, and then within the Hello World API resource, I have the type and the description and name and few other parameters. So this function configuration set the event to integrate with the API. Now next let's look at the Lambda function itself. The function is written in Python Boto 3. It's a very simple function. All it's doing is that it's returning a message hello world from Lambda, and then it's giving it back to the API as a response. So this is again just a simple function. It's checking the event and it's returning the response. Now look at the build spec YAML file. So a build spec YAML file is a configuration file that tells AWS Code Build how to build your project. It is written in a simple YAML format and does these main things. It sets up your build environment. It lists the command to run during different phases of building, like install phase where you install the dependency, pre-build phase for setup step before the main build, then there is a build phase where the actual building happens, and then there is a post-build phase for cleanup and final steps after building. It also defines what files to save after building and as artifacts like package SAM template, Lambda code, or test results. This file stays in the root of your source code repo and helps automate the build process as part of CI/CD pipeline with AWS Code Pipeline and AWS SAM. Here is an example of the build spec file, and if you look at it, it has different phases: the install phase, build phase, post-build, and then artifacts. So here it's saying, hey, in the install phase, install the runtime and the AWS CLI. There is a pre-build where it's putting few messages like pre-build phase, validating SAM template, and so on. And it's also doing the build here. And then there is a build phase where I'm packaging it, and then post-build where I'm deploying it. Structure is slightly different because I'm using this process with the AWS SAM, but in a traditional build process, like you can use it really how it's named. So you can install the dependency, you can do the build, you can then deploy it, and so on. So this is the structure of our build spec file for this current use case. Now let's look at the Git repo. So for this example, the GitHub repo is named Hello World CICD, and once your project files are ready, follow these steps to commit and push the code to your repo. Now git add, git commit, and git push, these are the standard commands. So basically really nothing special about them. I'm just simply adding the code to the Git repo by using these commands, and I have my build spec file, I have my hello world file, and JSON event and template, and so on. So all that is getting added to the Git repo. Now after pushing the code, navigate to your GitHub repo in the browser and verify that all files have been successfully updated. This ensures that pipeline will be able to fetch the source code correctly from the main branch. And this is how it looks in my GitHub repo. Now that we have the SAM template, Lambda code, and a Git repo ready, let's configure AWS Code Build to build the code and store the artifacts in a S3 bucket. To build a code build project using AWS Code Build, follow the steps as below. Go to your AWS console, look for the code build service, and then once you are in the service, then you create project. For that project, we'll select the source as GitHub, we'll select the environment as managed image, and for the compute, we'll select the build spec file, and then we'll create a new role, or we can use an existing role with necessary permission. In this use case, I'm gonna simply go with create new role. So here is how config code build project looks like. So we will provide a project name. I leave it to like default project, and then I'm picking my environment, which is saying, hey, say on demand, and here is the image, and I'm using the EC2 and the container and so on, right? So I'm picking a Unix image, and so this is how, like, this is a default basically I'm using. And then I'm saying my source is GitHub, and I have a connection to the GitHub already established. But if you don't already have a connection between code build and GitHub, then a new connection can be set up. So in this example, because I have the connection, it's gonna give me the repo, and I can pick the repo which is hello world CICD here. And then I'm also providing the build spec file here. And then I'm also providing the artifact repo, which is the S3 bucket, where all the artifacts will be stored. And then once I have this configuration in place, simply create build project. Now that the code build project is set up, let's configure AWS Code Pipeline to automate the CI/CD process. So for that, you navigate to AWS console, go to Code Pipeline, and click Create Pipeline. In that, we will specify the pipeline setting, the source stage, and the build stage. So for the pipeline setting, you can enter a name. I'm going to call it Hello World CI/CD. Optionally, I can select an S3 bucket to store pipeline artifact. And in the source stage, again, I'm providing the GitHub, and I'm providing the repo and the branch, which is main branch. And then I'm going to say change detection. So enable GitHub webhook for automatic trigger. And then I have the build stage where I'm going to select the AWS Code Build project. This is the build project that I have configured in the previous step using AWS Code Build service. And then in the deploy stage, actually I'm going to skip the deploy stage in this example because deployment is handled inside the build spec file using SAM deploy. So this deploy stage, I can skip it, and then I will get the option to review all my settings, and then I will simply click on create pipeline, right? So here is an example. I have the pipeline name, I have the properties, and then I'm saying, hey, the source is this GitHub. And then in the build, if you see, I'm picking the AWS Code Build as the provider, and then I'm picking the project that I created in the previous step. So this is basically bringing everything together, right? So with the AWS Code Pipeline successfully created with the configured source and build stage, now this pipeline is integrated with GitHub, so it will be automatically triggered whenever a new commit is pushed to the connected branch. So in this example below, you will see that it's saying the source stage has been successfully completed because it's saying all action succeeded, and then for the build, it's telling me that's in progress because it's trying to follow all these steps which are defined in the build spec file. Now, if the build stage does not complete and it fails, then you need to review the error message in the CloudWatch log and understand that why the build is failing. In this case, looking at my log here, it's saying it can't do S3 get object on a resource. So its failure is due to insufficient IAM policy. So that's why it's saying that one of the action failed, and it's basically giving me that error, which I can go in my log file and look at why exactly it failed. To resolve this error, you will need to add the necessary permission to the code build service role, allowing it to interact with required AWS services such as S3, CloudFormation, Lambda, and API Gateway. For demonstration purpose, I'm assigning the full access permission, but in a production environment, you should never do that. You should always follow the principle of least privilege and grant only the specific permission required. So here I'm attaching the policy like S3 full access, the CloudFormation full access, Lambda full access, and API gateway. So after updating the IAM permission, if I go back to the pipeline and I retry the build fail action, I will see that it moved from fail to in progress to succeeded for both these stages. So this is how it will look, right? So I am in the fail build. I have the option to retry. So if I click on retry, then it will go in progress. And then from there, because now I have fixed the permission issue, I should be able to see that all action succeeded. So this is how the pipeline is bringing everything together. Now, what does that mean that pipeline has been successfully executed? That means it has built the code, resulting it in the deployment of the Lambda function and its integration with an API gateway endpoint. So I have an API now. So let's validate the deployment by invoking the API. I'm going to use the Postman to send a request to the deployed API endpoint and review the response. Now, if you recall, my Lambda function is very simple. All it's doing is just giving the response back, hello from Lambda. And if you see here, when I invoke the API endpoint, that's exactly I'm getting. So API successfully returned the response defined in the Lambda function, confirming that the deployment and integrations were successful. Now, our use case is to make sure that code pipeline get triggered every time we make a change. So to validate that, let's make a change to the Lambda function and commit the updated code to the Git repo. Once the changes are pushed, this will automatically trigger the AWS Code Pipeline. And what I'm doing is, in this Lambda function, I'm simply updating the message hello world from Lambda to hello world from Girish, and I'm gonna commit the changes. The commit should actually trigger the pipeline, and then it will go through the build stages. So if I see here, as soon as I push the code change to Git repo, I see that pipeline has been kicked, and again my build is in progress. And because I already have all the build issue resolved, is actually gonna go in like all actions succeeded. What that means is that at this point, it has actually retrieved the code from the GitHub, and it has deployed it, it has built it, and it has deployed it in the AWS cloud. That means I have a refresh Lambda function, so I should not get the same response from the Lambda function which I was getting before. So to validate that, I can trigger the same API again, and if I do that, then you see here that I'm getting hello world from Girish, which is a new message that now I have put. So this confirms that changes were successfully deployed. Now I can also review the S3 bucket for code artifact, because in my code build project I said, hey, store my S3, like all the build artifact, store it there, so I can see these artifacts are there. And then I can also look at my CloudWatch, because CloudWatch is integrated function. So like I have a dedicated log group and I'm seeing all the logging message in the CloudWatch. Very helpful for typical debugging, the observability, and looking at that what's going on inside the code. Now, once you have completed the exercise, make sure to delete all the resources created to avoid unnecessary charges that could impact your overall cloud cost and budget. In particular, remember to delete the following: delete the AWS Code Pipeline, delete the AWS Code Build project, any S3 bucket used for artifact, and then Lambda function, API gateway, and associated CloudWatch log group. If you created a new IAM role, then delete those also if they are not going to be reused. So in this workshop, I demonstrated how to create a CICD pipeline for a Lambda function using AWS SAM. We used Python and Boto 3 to build a simple Lambda function and exposed it via API gateway. The deployment process was fully automated using AWS Code Pipeline integrated with GitHub for version control. Now, this was a very simple pipeline, but there are other use cases like introducing a manual approval process where you want someone to look at the build before pushing it to the higher environment, or adding a notification in case the build fails so that somebody can get notified and they can go and look at that why the build failed and fix the error and so on. So I'll be doing those use cases in the upcoming sessions, so stay tuned to that. I hope you found this tutorial both helpful and informative. I'm constantly working on new content covering various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue creating valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.